This is the first step in our application that we are going to evolve over the course of this ramp-up. We're going to start out with a monolithic application, and we're going to proceed to evolve it using the principles of partitioning and layering. So by the time we are done, at the end of the units, we will have a well-factored application that will show you the basic principles of partitioning and layering. So let's first look at the data structures inside this very simple customer manager application. At the base, we have a customer class that has a name and ID as private member variables. The constructor takes the name and initializes that name private member. And then we have properties that either can get the name or return or set the ID. We then have a customer manager class, which is designed to manage the customers in their collection. So we have a private sorted list of customers, which is created inside the customer manager constructor. And we have methods to add a customer taking a name, to remove a customer, to get a customer by name, to get a customer by ID, and list all the customers. And inside the main application, we create a new customer manager and use it to add customers. And then we try to get the customer by name and by ID and list all the customers. So if we run the application, that's exactly what happens. That you see, we've retrieved the customer, we've modified the customer, we've retrieved the customer by ID. Now, there are quite a few flaws in this application. One of which is that there's no encapsulation. We can create a new customer outside the customer manager. We can modify the customer ID outside the customer manager. And this, of course, could interfere with the storage of the application. The ID should be unmodifiable once it gets created. So the first problem is lack of encapsulation, because we could wind up with two customers with the same ID. The second is that this application being a monolithic application, we have to edit the whole application, recompile it, rebuild it all at once. Our first naive attempt to do a better job at partitioning and layering is simply divide our code up into separate assemblies. But when we run the program, we find out, of course, it runs exactly as before. And we have all the same problems in the main program that we had before. We haven't improved encapsulation. We have not changed fundamentally the way the program operates. Granted, we have 3 separate projects, so parts of the application can be worked on separately, but really, from the point of view of the logical design of the application, we haven't made any improvements. In our next step, we come up with a better logical design. And what we're going to do in this step is to illustrate the idea behind interface-based design. And this is actually our first attempt at serious partitioning and layering. We're going to keep our definition of the customer class the same, and we're going to define an interface called iCustomer, which is going to have a get method for both name and ID. And we're going to use the iCustomer to define something called the iCustomer Manager interface, which is going to be able to add and remove customers and able to get customers or individual customers. And notice everything is defined instead of using the customer class with iCustomer interface instances. The customer manager class implements iCustomer Manager, which means that we can manipulate the Customer Manager through this interface. And through the Customer Manager interface, we will only manipulate iCustomers instead of customers. And of course, iCustomer will only have getter properties, so we will not be able to modify anything that we should not be able to modify. There is no dependency in the Customer Manager on the customer object itself, except in add customer, where we use the customer constructor. Now we'll introduce our first pattern, a very simple singleton factory pattern, where we have the Customer Manager factory. Within the Customer Manager factory, we'll create an instance of Customer Manager and return an iCustomer Manager instance. So when the main program calls the factory to create the Customer Manager, it will only get an iCustomer Manager interface. So the only dependency on the actual object is in the factory. Now, we could have used a factor pattern in the Customer Manager class itself, so we would not have a dependency on the customer. But we did not do it. And this goes back to what we spoke about in the screencast, that nothing will have gained at the moment for this additional level of indirection. The dependency is still isolated in a single place. Here the factory isolates the dependency from the main function. Now that the main function has been rewritten to use this, so we create a Customer Manager factory instance, get back iCustomer Manager, we'll call add customer to add Harry, John, and Mary, and get customer through the Customer Manager interface. So it is impossible now in this main program to directly deal with customers or even the Customer Manager object itself. So we have introduced encapsulation. And of course, the application still runs in exactly the same way.